Today we're going to begin section 5.4. This is the fundamental theorem of calculus. The fundamental theorem of calculus enables us to evaluate a definite integral. The theorem says if the function is continuous and closed on the interval from a to b, then capital F is the antiderivative of lower f on the interval a to b. So look at the integral here. If we're trying to find the integral from lower bound a to upper bound b of the function, what we need to do is find the antiderivative of the function and then plug in the upper bound minus the lower bound. And that is the fundamental theorem of calculus. So let's try an example. If we want to find the integral from 1 to 3 of x cubed, what we first need to do is find the antiderivative of x cubed. So that means we're going to add 1 to the power and then divide by the new power. We are now going to evaluate from 3 to 1. What that means is plug 3 into our antiderivative minus plug 1 into the antiderivative. And that will give us the definite integral. This is the area under x cubed from 1 to 3. The answer to this is 20 units. Let's try the next one. We want the integral from 1 to 2 of the parabola x squared minus 3. So first let's find the derivative of x squared minus 3. The antiderivative. The antiderivative of x squared is 1/3 x cubed. The antiderivative of negative 3 is negative 3x. We're going to evaluate this from 2 to 1. And what that means is we're going to plug 2 in for both x's minus plug 1 in for both x's. And now let's figure out this computation. 2 cubed is 8, so I have 8/3 minus 6. 1 cubed is 1, so I have 1/3 minus 3. If I change 6 to thirds, that means I have 8/3 minus 18/3, which would be negative 10/3. 1/3, change 3 to thirds as well. 1/3 minus 9/3 is negative 8/3, and then I'm going to subtract that, which gives me a final answer of negative 2/3. Please be careful with this minus. Make sure you minus all of the second part there, and be careful working with your fractions. Let's try another. First, in order for us to find this, we want to rewrite this as x to a half. Now it's a little bit easier to find the antiderivative. The antiderivative, we're going to add 1 to 1/2, which makes it 3/2, and put the reciprocal in front, which would be 2/3. But I already have a 3 in front, so really it's just going to be 2. 2/3 times 3 will be 2. Now we are going to evaluate from 4 to 1. So plug 4 in minus plug 1 in. I'm going to evaluate this. First I'm going to do 4 to the half power, which is the square root of 4 is 2, and then 2 cubed is 8. 8 times the 2 in front will be 16. 1 to any power is 1, times 2 is 2, so 16 minus 2, and get a definite integral of 14 units. Notice we're getting an exact answer. We are not sketching it and finding the rectangle estimated area or even a trapezoid estimated area. We're finding the exact area using antiderivatives. Now let's look at the next one. First, figure out the antiderivative of secant squared. What did secant squared come from? It came from tan. Now let's evaluate from pi over 4 to 0. So plug pi over 4 in for the x, minus plug in 0. Tangent of pi over 4. Let's think about our unit circle. Pi over 4 has a coordinates of radical 2 over 2, radical 2 over 2. The tangent would be the y over the x, which is 1. The tangent at 0 will be y over x, so 0 over 1, which is 0. So 1 minus 0 will be a definite integral of 1 unit. Let's look at the next example. We want to find the area of the region bounded by this graph. If I were to sketch this graph, it is a parabola. It does cross the y-axis at 2. It looks like this. Oh, I'm off a little bit. Right there. It should cross at 2. And we want to find the area of the region bounded by this graph, the x-axis, and between 0 and 2. So this shaded region here. What you want to do is write your integral, which is given for us, from 0 to 2 of the function. So how do we use the fundamental theory of calculus? Let's find the antiderivative of the function, adding 1 to the first term, and then dividing by that new power, adding 1 and divide by that power, and adding 1. Now we need to evaluate from 2 to 0. That means you're going to plug 2 in for every single x. Notice I plugged 2 in for every x, minus plug 0 in for every x, which I can see plugging 0 in everywhere is just going to be 0. Now let's evaluate. 2 cubed is 8. So 8 times 2/3 will be 16/3. 2 squared is 4. 4 times 3 is 12, so I have 12 halves. And then 2 times 2 is 4. You can then, well, 12 halves I could have written as a 6. I'm still going to need to make common denominators, make them all thirds. So I'll have 16/3. 6 will turn into 8/3. 4 will turn into 12/3. So I could do 16 minus 18 is -2, plus 12 will be 10/3, minus the 0, which is still just 10/3 as your final answer. Now we're going to switch it up a little bit. Let's talk about the mean value theorem for integrals. If a function on the closed interval and it's continuous, then there exists a number c in the closed interval such that this is true. Now the value of f of c is the mean value theorem for integrals and is called the average value of f on the interval a to b. So it's kind of like finding the average value across the area. So if we want to find the area under the curve from point A to point B, the f of c will be the average area per unit. And we can do that by this formula here. So let's try an example. Remember, don't let the formula scare you. Think about what average means. If you had to average your grades, you're going to add it up, find the total, and divide it by the number of grades you had. So this integral portion is finding the total area, and this 1 over b minus a is basically dividing by the number of units you covered. So let's first write it out. F of c will be 1 over b minus a. So that's the upper bound minus the lower bound of the integral from 1 to 4 of the function 3x squared minus 2x dx. So now let's compute this. The fraction will just be 1/3, and now let's do the integral. We're going to find the antiderivative of the function and evaluate from 4 to 1. So I'm keeping the 1/3 outside, plugging in 4. I get 4 cubed minus 4 squared minus plug in 1. 1 cubed minus 1 squared. After evaluating the integral, I get a value of 48. So the area under the curve from 1 to 4 is 48 units. If you want to find the average across the 3 units, just divide by a 3 or times it by 1/3 and get an average value of 16.